Good day, everyone. We will have a tech talk today given by Daniel, who joined DKRZ in 2019 and was a scientific HPC user before that. And since we have StrongLink, he is responsible for user support of the tape archive. And he will give a talk today about the tape archive, archival basics, and some best practices, something command line interface usage, preferred file sizes, how to pack the data for archival, and how you can verify whether your files were properly archived. Daniel.
Great, thanks, Alex. So, hi, welcome in the room and remote. Nice to have you all here. Yeah, as announced, I will talk about it today. So we have a QA document in the background. Flo just posted the link to it to the chat. So if you have online some questions, just post them there. We have two people who are there and care a bit for the questions, maybe answer them already. These are Heidi and Michael. Heidi is from the systems department, does a lot of StrongLink administration in the background. So she's one of those who keep it running in the background. And Michael, he's my substitute for HSM support. So if I'm not there, he's there. Yeah, here also a QR code. I don't know if someone here wants with mobile device wants to join the QR document. And also we have this DKRZ documentation page and HSM documentation, also specific archivists page. That's slightly outdated, or it's not, the overview is not well, and so it's not well structured. In the moment, we are currently restructuring the documentation of the HSM, and we hope that it's finished in 2 weeks. So in the moment, it's not too nice, so maybe wait 2 more weeks before you really deeply look into it again. So I don't give a really detailed overview here, but generally I will give a short introduction. And the last time I talked here, I had short breaks in between where we did some exercises. And I didn't get negative feedback, and therefore I thought I'd do it today again. If you don't like it, please give me feedback. If you like it, please give me feedback. I think we are sitting the whole day in our office, and maybe it's good to get up and move us a bit. And so in the general structure, we have a short mental breaks, and we have a theory or a background part, and then some examples. And so all examples are in the presentation here. I won't do anything in the terminal, but they're more or less terminal screenshots, and so you can reproduce the things later on, which I did here. We have different tools. So just a question, who worked with SRK before? Are there some users here who never worked with this SRK tool? As online someone, maybe you can write in the chat if there's someone who's really new to it. Okay, so everyone only the basics, okay. Okay, great, perfect. Then we use it, okay, great, perfect. And also the talk is meant in a way that it's targeted also on users who never worked with it before. If you worked with it before a lot of times, then you're also welcome. So we have different tools, and in the beginning it might be a bit confusing with which tools we have. And therefore I just posted the most important ones here. So we have first the SRK. This is the basic command line tool provided by the company who developed the software for our HSM. So the software is called StrongLink, and the official command line tool for the software is called SRK. And then we have SRK helpers. That's, let's say, an extension to SRK, which adds new features, but which is developed at DKRZ. And so in the moment, it's the way SRK is not further developed, because we are the only customer of StrongLink who really needs this command line interface, and therefore it's the way it is. And everything we want to have more, we add via SRK helpers. And then we have PACAMS. PACAMS is actually a wrapper. It works around SRK and SRK helpers, and it supports you packing data and archiving data. So it was originally developed by Kalle, who's also here today. And so now it's co-development by MPI, M, and DKRZ. And we will soon also install a new PACM's version. And then we have PySRK, that's a Python library to access the tape archive. It's actually a wrapper library around SRK and SRK helpers. Thus, cannot do more than SRK can do. But it's made for Python. There are also Python pandas data frames, return partly, and so on. So it's we try to make it somehow Pythonic. And we will soon install a really new version in the default Python module on Levanter. But PySRK is today not the topic, just you know that this exists. And for archival and retrieval tasks, I would suggest not to use PySRK. So for all other tasks, searching files, changing permissions, any other tasks, checking whether files are in cache, PySRK is really, I think personally, nicely to use, particularly the new version. But if you really want to archive and retrieve data currently, I would suggest to use SRK, SRK helpers, and some scripts. What's important before you use SRK archive and retrieve first? So those of you who never used it before, you don't know SRK archive and retrieve. So you should know SRK has different subcommands to archive data, to retrieve data, to change user permissions, to check whether a file exists, check whether a file, whatever. And these commands to archive and retrieve data, they use a lot of memory, up to 4 GB. And this means if you use it on a local node, you use a lot of memory, which is not nice for other users. And also, if you use really 4 GB of memory, your SRK process will be killed by the system. And therefore, please do not use these commands, SRK archive, retrieve, and PACMs on the local nodes, at least when you deal with large files. When you work with some small test files, it's okay, but large files, please not. Instead, please use an interactive Slurm session via slog, or write a Slurm batch script and submit it via sbatch. And when you do this, you should allocate sufficient memory, and we suggest to allocate 6 GB of memory, 4 GB for the pure copying process, and 2 GB overhead. And 5 GB is sometimes a bit low, just as the beginning, so that's it, let you know that. And we'll start with the basic example. When we start with the examples, we have some training data. It's already all training data from 3 years ago. You find it in the Lastro file system. So if you want to do some training stuff, you can use these data, which are here. And I will mostly just work with 10 test files, which are just numbers, that's it. And for today, we have a training, a sandbox folder in the HSM. So if we want to list content in the HSM, we can have a command slk list, then we give a path which we want to list. And this is a sandbox path. We will leave it available until this Friday or mid of next week. So if one of you wants to reproduce stuff, which we did here today, you can do it there. Please do not archive large files. The data there is not written on the tape, it's just on a hard disk, but it's somehow you can emulate the tape access there. If you archive your own data and you never did it before, there are two so-called namespaces into which you can archive data, the normal arc namespace and double. And what's the difference between these, I will talk about later on. And data is archived on project basis, so you archive data into arc and then the project folder. So it's your computer and project. And the same for double. So if I want to archive data, I simply run a command called slk archive. Then I give a file name of a file which I want to archive and a target destination where it's copied to. And then when it is successful, there's a message non-recursive archival completed. I don't see progress here. What's quite nice, the target folder is automatically created, so I do not need to create it manually before it's just created. If I archive a large file from a local node, I will see something like this. I archive a large file, and then I will get some strange line where it's written killed in it. Often it's line 60, normally it's line 16, then a number, and then killed. This commonly means that you had too low memory available for your task you wanted to do. If you see this, then yeah, you need to allocate more memory the next time when you work with it. On the local nodes, you cannot allocate memory just on this, the active nodes. So just a basic example how to do this interact via salloc. So you run this command salloc. It's described in the DKRZ documentation. You have to provide a compute time project for compute time. You have to provide where you want to work on the so-called partition and allocate memory. And then you come to a specific compute node on which you can work. You have 6 GB of memory and say you can archive your file, and it's normally archived. So SRK Archive provides a verbose mode and a double verbose mode. In the normal verbose mode, you get a progress bar, and this progress bar is dynamically updated during the while you're archiving. This is not captured by Slurm logs, so you won't see this later in your Slurm log, and you also cannot pipe it somewhere. It's just there when you run it interactively. And then we have a double verbose mode -VV. And that's the bottom line. And there is, for each file which is archived, there's a line printed stating the state. So if the file was successfully archived, we have here the example, file 2 was successful, but there might be also written failed or skipped. Now, what I personally recommend if you use SRK Archive in scripts, I would recommend this bottom version, because then you really see which file was archived and which file maybe failed or which was skipped. I said before, it says some archive can fail, be skipped, or be successful. What's important here, if a file is skipped, so you see it's success, the file was transferred successfully, and the summary line states archival completed. If a file is skipped, skipping is also considered as a success, more or less, so the archive is completed successfully, and if it fails, then the summary message says it's failed. So if all files you archive are skipped for certain reasons, which I will mention later, then you get a successful archival at the end. Or it's printed as successful. So now I would like to do a short exercise just to get your mind free. So as I said, if you don't like it, just notify me. Please notify me. If you like it, also notify me, please. Just sit straight and roll your shoulders back 10 times. And when you did this 10 times, then you just bow your shoulders to the front and bow your back a bit. And you can remain seating. And then you come up again and roll again your shoulders back 10 times. And I would also be really interested, honestly, I would be really interested in your feedback. Does it also help? I mean, I'm talking about a lot of information. It has to go in our heads, and sometimes it's maybe nice to have a short time where we don't get new information. And so maybe it also helps to get the input into our heads. So I would be really interested in your feedback later on this theory and background part. So skipping, I said before, a file can be skipped. So when is a file skipped? And these two commands, SRK Archive for archiving stuff to the tape archive and retrieve for getting it back, they behave differently, and therefore I mention it here. So if we archive a file, and at the target destination, there exists already a file with the same name, same size, and the same modification date, then it's skipped. Modification date means the modification date is the file modification date. So I think the POSIX M time. So it's not the archival time stronic, but the modification time of this file, and then it's skipped. If one of the things does not agree, then it's overwritten. So if the file is a byte larger or smaller, then it's overwritten. And there's no parameter which we can specify to prevent this. So it's always overwritten if modification date does not match. SRK retrieve works differently. When we get data back, the default is to overwrite the file, independent of size or timestamp. We can set a parameter -s. This will cause SRK retrieve to skip files independent of the size. So even if we get a file back and the file we have locally, if it's older than the file we want to get back, then it's skipped anyway. So there's nothing I checked, and we have minus lowercase d. That means a duplicate is created. So the existing file, it remains there, and the new file is copied, and it gets duplicate appended to its name. But it gets only that there's no number added. So if I get 10 different files back, all of the same name to the same location, then the duplicate will be overwritten each time. So it's not numbered 1, 2, 3, 4, 5. Okay, practical examples to this. We have a file 01. We archived it successfully to a location. Then we run SRK archive again, same file, same destination, it's skipped. Then we touch our local file, so the timestamp is updated. We archive it again, same file, same destination, successful, so it's then overwritten automatically. And if we use SRK archiving scripts, it's quite nice to use so-called exit codes. So some of you might know it, some others not. Exit code means that we can, after command run in the terminal like this SRK archive, we can print the variable $? Or store it somewhere else. And this contains a number. And if it's a 0, then the command commonly was successful. And if it's a 1, then it was not successful. So if SRK archive was successful, then it's 0. And otherwise, it failed, we have 1. That's the default. Or if a file is skipped, then it's also considered as 0 as success. Another way to check whether an SRK command was successful or not is to look into the log file. So it is stored always in your home folder, in a subfolder .srk, and then always has the same name. Every SRK command which you run writes verbose output into this log. And when it has a certain size, then some files are removed, then some lines are removed at the top. So not your whole command history is stored there, but only the last. Yeah, don't know. It depends on how much I want to use it. And there you get, if you did an SRK archive, you see here a timestamp when I use the SRK archive. There's also written on which node on Levanta used it. This is a process ID. This is useful to map the log entries. So here, for example, I have the process ID, this one, this example below, I have another one. And so I can search for all lines which contain this ID, and so map together which log entries belong together. And there I see from my archival command, so I shortened it a bit, normally there's printed more. I get an archival report, a status success, and I see the amount of data which was archived. Or if it failed, there's also some information printed why it failed. This time no such file exception because a file didn't exist which I wanted to archive. And this report is printed for archival and retrieval, it's printed there. It gets a bit messy if you run in parallel 5 or 10 archivals and other commands, automatized scripts, and it's really a bit messy. But for this purpose, you can use these process IDs to collect the entries which belong together. Now, if I archived a lot of stuff, I want to see what's there. For this purpose, I can use SRK list. And with this, I can list folder contents, and it's SRK, actually the output of SRK list, it's like the output of ls minus LA. And we see permissions, owner, group, size, timestamp. That's the timestamp, not of the archival, but the modification time of the file. So if I created a file 3 years ago, and if I archived it yesterday, then I would have the timestamp from 3 years ago here. Other questions?
How's the exit code that you showed? How is that different from the status that comes with SRK? So it's kind of just a double way of documenting success or failure? Yeah,
or if you have, for example, if you use SRK archive in a script, then it's quite easy with the if to capture this. It's a bit easier than to pass the text out. So that's the main reason for scripting. Other questions? Okay. Great, then we do a short focus break again, and I would ask you to get up and do the same thing like before, stand straight and just roll your shoulders. And when you finish doing it 10 times, you round your back, shoulders. And roll your shoulders again 10 times. Okay. So again, it's series section. So this is a quite a large slide with lots of information on it. I wasn't sure if I should show it today, but I think for understanding why certain things don't work nicely or may take longer, it's quite important to have this information. So if you archive data, so normally your data is somewhere on the Lustre file system accessible via Levante, and then you want to archive data via SRK archive. Then it goes to the so-called storing system, and that's written into the cache. The cache is also disk storage, not a tape yet, but only disk storage, and there it is. And then we have the tape storage. So we have different so-called tape libraries. So big boxes with tapes in it here at DKRZ, and also location in Garching. There's our second or backup tape location. And if you archive data to this ARC namespace and then project, then the data is later written to tapes in Hamburg. If you archive it to double, it's written to Hamburg and to Garching. And it's always written only to one tape at this location. So if I archive data to Hamburg, it's written to one tape in Hamburg. You say, okay, it's really important data, it should survive fire and DKRZ, then you should copy it to double. The disadvantage is you have two different namespaces, and maybe you don't know later where's the data stored. And when the data is in the cache, storing decides on different heuristics, or also depending on file size and other information, at some point to write the data to tape. And to tape at DKRZ, and to tape in Garching if you selected this, if you copy data to double. If you archive data to double, it costs you twice the quota you normally would use for your archive. So the important message here is if you archive data, if you use SRK archive to archive data, it's not instantly written to tape, but it might take a day, an hour, or a week, maybe, depending on different boundary conditions. You don't have direct access to Garching. You just know if you archive data to double, then it's at some point written to Garching, and it can be get back. But so if you archive it now and in 1 hour the DKRZ burns down, then the data was not written to Garching yet. It will be lost. So it might take some time until it is there. Or for those of you who are new to archiving data, just really briefly, if you archive, I just call this archival, what I'm presenting here, I just call it here self-service archival. It's not the official way how we name it, but just in this presentation, if you archive it there to a project, then the data remains there for the lifetime of the project plus 1 year. And after that, it's deleted. So you can do it yourself as a user, and you can use SRK for it. If you have publication data which you want to archive, then we have different means. We have so-called long-term archival LTA, there's the WDCC, World Data Center for Climate, and so-called DOKU. And this is meant for, let's say, publication data here. And for example, we have IDEAN here, and if you want to archive data to DOKU, then contact DKRZ, then we'll probably talk to IDEAN about this. You cannot do it yourself. You have to provide the data, and DKRZ staff copies for you to this location. And there are certain things, so for WDCC data publication, you get in DOI, the data will be publicly available. So there are different advantages of the different use cases compared to just self-service archival with SRK. Depending on your use case, just to know about it. Those also externally who are new, maybe at DKRZ. And here you have the link also when you download the presentation later to where the difference between WDCC and DOKU are presented. You can click on it later. Just briefly. So Now I archive data and I want to know, well, where is my data stored? Because if data is stored on tape, I cannot get the data instantly. It takes some time. If the data is only on tape, then the tape is somewhere in a shelf. And when I want to have a file from it, then the robot arm comes, takes the tape from a shelf, brings it to a tape drive, inserts it, and the tape has like an old music cassette, has to spool to a location, then the file is read. So it takes some time if the file is only on tape. But if the file is still or already in the cache, then it can be quite quickly accessed. And therefore, for your use case, for your daily work, it might be interesting to see whether a file is already in the cache or not. Right, and so the simplest tool which we can use is SRK-list, and if we use SRK-list and list the content of the demo folder of mine, then the last character of the permission string, that's not a permission, but that indicates the storage location. And if there's just a minus sign, dash, then it means there's nearly no waiting time. No waiting time, the file is in the cache, and T means the file is only on tape. And you have to expect certain waiting time to get the files back. If there's no T here, you don't know if the file is already also on tape or not. So you get no information if a file is in cache and on tape, or only in the cache, you don't see it here. For this purpose, we have also other tools. So SRK-list shows you as a user and gives you a nice view as a user. If you want in a script to decide, if you want to decide in a script based on the caching state of a tape on a file, just a second. For this purpose, we have the command is cached, and with is cached, we can check. We can ask Stronning, is the file in the cache or not? And is it also, it has also verbose mode to print some detailed information. You don't need to understand it now. You can also look at it later, but just to know there's such a command. There's also another command is on tape. So if I archive the file and want to know after 2 days, is the file already written to tape or not? Then I can use this command and see whether the file is already on tape or not. Right, without this exercise section now, just some more theory background. I talked about exit codes. And what I want to mention here is, and also why I mentioned the commands on the slides before, the 2 slides, is that SRK and SRK helpers have different exit codes. So SRK just knows 0 and 1, and 0 means success, and 1 is failed. For SRK helpers, we decided for certain reasons to have it more granular. So we have 0, 1, 2, and 3. Some other command line tools like ls or grep also have this more granular. And 0 means successful or yes. And 1 is something special. I will show you on the next slide what's special. 2 is a general error or general failed, and 3 is a timeout error. And we introduce this timeout error because if there's a high load on Stronling, so if a lot of users are archiving data, then the system becomes somehow slow. And if you then do a lot of operations, you might get timeout errors. And if you get a timeout error, it's reasonable to just wait 5 minutes and retry the same command again. And for this purpose, we introduce this error so that if you have a script and use SRK helpers commands in your script, then you can catch exit code 3 and say, okay, if exit code 3 comes out, then please do the same command again in 5 minutes. And now examples for this exit code 1, for which it is used, for which use case it is made. So if we have a command SRK helpers exists, and if we check for a file exists and the file exists, then we get exit code 0. If the file does not exist, but there's no other errors, then we get a 1. And if the command fails for whatever other reasons, then we get a 2. So for example, the command accepts only 1 input argument, but we provide 2, then we get an error and the 2 as exit code. So in general, with the SRK helpers, we use this exit code 0 and 1 for yes/no questions. Same as for this is cached command. We ask, is this file cached? The file is cached. Exit code 0. We ask, is this file which is named not cached. Is it cached? It's not cached. Then we get exit code 1. And so we can easily use in a script in a if case and build on this. And if for this command is cached, if a file does not exist at all, then we get an error, and this is exit code 2. So for those who want to use it in scripts. Other questions? Online. So if you have online questions, just write it to the QA document, and then we can answer it also later. Okay, next focus break. So just should sit straight, and then I would like to ask you to look to the right, and then to the left, and just repeat it 4 times to each side. So in total, 5 times right and 5 times left. Some theory and background again. File size rules. So first, in general, files, so because I'm asked this often, and therefore I'm just stating as the first item here, files larger than 1 terabyte are possible, and they are tested. So we tested 2 to 3 terabytes, that works. The largest file in the tape archive is 6 terabytes, that also works. It takes long to get it back. We really discourage you to do this, but in theory it works. So there's no certain point at which files may be cut. We recommend file sizes between 10 gigabytes and 200 gigabytes. Why? So the lower limit, it's to optimize read speed. I have 2 more slides on this to explain it so that you understand why this is the case. And the upper limit is more of observation based. So our current hardware setup plus a strongly software. In this setup, we observe that if files are larger than 250 gigabytes, then the writing from cache to tape, it gets slower due to reasons. And if we get it back from tape, it also gets slower. And therefore, if you want to have optimal read-write speed, you should remain below 200 to 250 gigabytes per file. And also, when you run SRK archive, with 1 call of SRK archive, please do not archive more than 3 terabytes. The background is here. If you initialize a connection with SRK to strong link, then you are randomly mapped to one of 11 strong nodes. So there are 11 servers, and if you use SRK, you're connected to 1. And the server, if you copy data to it, it accepts the data and does some post-processing. So it calculates a checksum, it does other stuff, some different things. And if you copy too much data at once to one node, then it gets overloaded, becomes very slow, and you can get a connection interruption. Therefore, we strongly recommend, and this occurs roughly at 3 to 5 terabytes. And therefore, our recommendation is archive just maximum 3 terabytes with 1 call, can be many files, and then for each set, new SRK archive call. And so if you do a new SRK archive call, also if you do 2 in parallel, then you are connected to 2 different nodes, probably, and so the load will be better distributed. So why do we have this lower limit? So some background. So if we read a file from tape, as I said before, there's a shelf with tapes in it, and the robot comes, takes the tape out, brings it to a drive, and then the drive has to spool first to the location where the file starts. Then it starts reading the file, the speed increases, it goes quite quick in a second, don't have exact numbers, so it's just a schema here. And then it has top speed. For our modern tape drives, for data which is archived now with strong link, the speed is 300 megabytes per second. And then when nearly the file end is reached, then it becomes slower again. And then the file is completely read. And each start-stop operation, it harms the tape a bit and it reduces the tape lifetime. So we should not just for fun start stopping a tape and spool it for fun. And so if we have 100 gigabytes of data we want to store, and we have on the one side one big 100 gigabyte file, and on the other side 1,100 megabyte files, then we have schema. Here's two schematic plots. The green one is one big file, so the tape spools under the beginning, reads the file quickly, and then it's done. But quickly, it takes some time, but at least that's a long time span where it's probably read at top speed. The tape drives have certain heuristics when they might read it slower under certain conditions, but just assume it's normally top speed. But if you have many small files, then the tape drive has to spool to the start of the first file, read it, and before it reaches the top read speed, it already has to decrease speed because the file soon ends. As we see 300 megabytes per second, it can read top speed and only 100 megabyte file size, then you can imagine. Yeah. And so maybe there are also two files after each other, then it can read a bit more efficient, and it would go on to the right, further to the right. It would, so as you see, it will take much longer to get these 1,100 megabyte files back compared to one 100 gigabyte file. And the other aspect is this is start stops for the small files. If they hurt the tape, and the tape will fail earlier, might get damaged. And therefore, it's reasonable for your own retrieval speed later and also for tape lifetime to somehow archive large files. How do I do this? So the one thing is, so please pack files. I will give example after that. You can do it manually in tarballs, zip files, or you can use packings for this. And the other thing is, please check whether there are hidden files which you might accidentally archive. So we did beginning of this year, we realized some users accidentally archive .git folders, and the .git folder contains a lot of small files. And it might happen quite quickly. So you have to finish a project, you want to archive your data, just say, okay, archive everything. And you maybe packed the folders, when you do ls, you don't see the .git folder. And so maybe you packed all the files you see, but you forgot there's a .git folder or .svn folder, or if you have Jupyter notebooks, you have a .ipynb checkpoints folder. And so if you don't want to archive these folders, you can look manually for them, or you can run SRK archive with -x. And this will skip automatically all files and folders which start with a dot. It's not the default because maybe user wants to archive such files and then maybe loses data because these files are not archived. Therefore, default is archive everything. But if you know you don't want to archive these things, just run it with this. And actually, we forgot to add this documentation, so in future it will be in the documentation. Examples. So just as you see here, an example for this -x option. So we have a demo folder here. We have a .config file, a .git folder, and two files, and we run line below SRK archive with -x. And -vv for both mode, and then we see here's a list of files which are archived, and we see only our netcdf files are archived, and the others are not mentioned at all. Then packing data. So what we now want to do is we have a lot of small files, 10 small files, and we want all other questions first. Yeah. Yeah, I think we will put them in Indigo. I will give them to Flo and Alex, and I will upload them and you can get them. Yeah. So now we have a use case. We have 10 small files and we want to archive them. And the common workflow would be probably, or currently the common workflow is we have the data stored on work, and then maybe we create a folder in Scratch and just pack everything with tar. And then we archive the files to strongly. And if we do it manually, so just, I realize we're a bit short of time and I'm talking too long. So just if you do it manually, some of you know, maybe others can look it up later here. You just pack the files and archive them with SRK archive. We have this tool called Packems, which Kalle developed, which actually does this packing work for you. So the aim of Packems is that I have data in work, and I tell Packems, okay, please Packems take this data from work, please put it into tarballs first in Scratch, and then later archive these tarballs to StrongLink. And please put the files together in tarballs of, let's say, 100 gigabyte per tarball. This is also default 1 gigabyte. And I do not have to care, I do not have to collect the files and see which file goes to which table. It just does it. And it also creates me in the end an overview file, a so-called index file, which contains information which original file is maybe stored in which table. The command call is quite long. I won't look into detail here. You can look it up later. I just would like to mention, due to the issue I mentioned in the beginning, that there might be timeout issues when we use SRK archive. It's reasonable. So PACAMS is originally meant to do everything in one, pack and directly archive. Our recommendation is to use PACAMS first to pack data and then to archive it in 2 steps. And for this, we recommend to run PACAMS first with no archive option and different other options for different things, which are described here at the top, which you can look at later on. And then run it a second time when the first is done with a flag archive only, then it will archive everything which was packed before. You can also parallelize it as described in documentation. And what it also does, in the end, it archives a tarball to it. So here we list the target folder in the HSM where we archived some things. So it creates a tarball or multiple tarballs and a file called index.txt. And this contains a list of files which are in the tarball. So if I want to see later on which files are in this tarball, I just have to get this index.txt and can look into it. And if I have, for example, this is a use case of mine, really a lot of tarballs, then the information which original file is stored in which tarball, that's stored in this index file. And I can look in this index file up which tarball I really need in the end to get my data back. And we have also tools to do this automatically. It's a written documentation. As this structure might change in the future, so we are discussing to put this index file somewhere else, but in the moment it's in the same folder where the data is stored. Other quick questions? So you're welcome just to try it. If you have questions, just contact us via support@dkrz.de and we'll try to support you. I will skip this focus break because of shortness of time. You can do it on your own if you wish while I'm talking. Incompletely archived files. So let's say we have a list of source files here, and this should just indicate we have files. So a file with this is 1.1 gigabyte in size, file with B, D, E, F, G, H, I, J. So a lot of files. They are all 1.1 gigabyte, and I run SRK archive, and maybe I forgot I do it on a login node, and then I get this then it's killed because I have too less memory allocated. Then I get something that's killed, and then yeah, what's then? First, there are different situations when it might get killed, as I said, out of memory, so-called OOM kill, which we can do, as I mentioned at the beginning, what we can do against. Then what also maybe happens if SRK archive takes longer than expected and you have a Slurm job, which runs for 2 hours. We have an end time of 2 hours set, and SRK archive will take longer, then the Slurm job ends and SRK archive dies. Might have connection timeout due to a storing issue, or maybe you killed SRK archive manually because of whatever reasons. Your SSH session died because of internet connection loss. And now you are suddenly there and you do SRK list on the folder on which you just archive data, and then you see, so the color, I made the color. So you see some files here have 1 gigabyte in size. There's just a file name, and there's also where the dots are, there's some more information in between. So there's file size, timestamp, whatever. That's not important. Important is size, the name, and for some files, there's brackets printed partial file. And what's a bit confusing, you have some files which are 1.1 gigabytes, which don't have partial file, then some which have this expected size and have partial file, and some who are differently have the wrong size, 0 byte, or here it's some 144 megabytes. So these red marked files, they are definitely defect. The green are probably okay. And the orange ones, we are maybe a bit unsure. So there is a partial file is written there, so we call it a partial file flag, but size seems to be okay. So what's about there? And And what's even more strange, so you see, you can maybe see the pattern here. So the files 3 and 4, C and D, don't have partial files, the other have it. And now I use SLK-chmod to change permissions for one of the files, for the file with an I. If I do SLK-list again, then here are different permissions, they are not important, but suddenly the flag is gone. And that's actually due to an error in SLK that is not shown anymore. So it's still there, but you don't see it. That's another issue here with SLK-list. We have a specific command with which you can check whether the file is set or not. Just to know, you can look it up in documentation. And so there are some things we should remember at this point. If we archive files and we do SLK-list and we see a file via SLK-list, then it's not necessarily completely archived. So files which are only half archived are still printed by SLK-list. So we cannot do this for verification of correct archivals. HPSS work differently. There these files were not shown, but the philosophy of the Strongnink developers was they want to prevent data loss, and therefore even if a file is only half archived, then at least the first half of the file is there. And if the original file is gone, then we can save it. Yeah, so we can at least save the first part of the file. Can discuss it if reasonable or not, depends on the file format. And second point is this partial flag is not only printed, so there might be a file which is actually damaged, like this 144 megabyte, and this partial file info is not printed. And what's also important, I didn't show it here, but just trust me, if a file is flagged here, then we cannot retrieve it. So it's a safety measure that there's a defect file in the tape archive, and it might happen that the user retrieves it and works with it, and something bad happens, and then this should be prevented, therefore retrieval is blocked. And now you probably ask yourself, what do I do then? So there are so many possibilities. Like, what do I do in my everyday life? So if you want to have a detailed decision tree, so actually it's quite simple, and so it has. I'm briefly going through it, and for different applications, it might be useful to have this. So you have a file. You come here at the top, and you see a file is stored on tape. Then you can be sure the file is okay, because before Strongnink writes a file to tape, it checks if the file size is the expected file size. So when we start SLK archive, then Strongnink writes down the file size of the source file into a database. We cannot see this file size. Also, we, DKRZ, cannot see it, only the Strongnink developers and a certain other tool, which I will show, but it's somewhere there in the background. And when Strongnink writes a file to tape, then it checks this file size in the background. Does it agree with the real file size? And if it does agree, then everything's probably okay, then it's written to tape. So if you see a file where a partial file is printed, but SLK-list here in the first column says it's on tape, then everything is actually fine. You cannot retrieve it, but it's on tape. Then, if the file is not on tape, you can check the file size. I mean, if there's a size of 0, and the source file also has the size of 0, then everything is fine. If not, it's clear this is an issue, you have to re-archive it. Then, if it has no partial flag, then also everything is okay. But you should not check this with SLK-list, but with a specific other command for it called has no partial flag. So what I write here as text, just with an underscore, is a Gelber's command, find it in documentation. And with this command, you can check whether a file is flagged or not. And if this command tells you the file is not flagged, then everything is okay. And you do not have to care otherwise. Yeah. And then is the case the file is flagged and it's not stored on tape and is larger than 0. And then you can do two different things. You can get the checksums, so Strongnink calculate checksums for each file. It's not directly calculated. So if Strongnink is under high load, it might wait a week until the checksum is calculated, but it calculates checksums. And the other option, which I show you today, is run a so-called verify job. And this verify job, what it does actually, does the same as what is done in the beginning for writing to tape. It checks the file size. Checks, yeah, Carlo?
I don't find the case that you had with the 144 megabyte files here, right? So where the partial flag has been deleted before.
Yeah, so actually the flag is still there, but SLK-list just doesn't print it.
So there has no partial flag which shows but the last time.
Right, yeah, the command, yeah, right. The command has no partial flag, it shows the flag, but SLK-list doesn't show it anymore. And why I'm talking about this and why I invest time, which most of you maybe say, okay, why didn't we skip it? So if you have a script maybe and you want a quick check directly after archival, then the things which are marked in violet, they are quite, you can quick this instantly after archival, or you can check it instantly every time you want. You do not have to wait for it, you just check the file size, check this partial flag, and that's it. If you run the so-called verify jobs, these verify jobs, they might take a bit of time because these verify jobs, if you send them to strong links, they come into a queue. And strong link has one big queue, and it's made for retrievals of files and for verification checks. And so if a lot of users are retrieving data, and the queue is very long and users have to wait to get the data back, then your verify job also has to wait in this queue. The background for this is that this verify job also, you can do other verifications with this as well, like checksum verifications and other stuff. And therefore, it's actually the same as the retrieval because it also can retrieve files on its own. So we can set up verify jobs to do some auto verification. So we can randomly tell Strong just get some files back from tape and check whether they are okay. And because of this verify job, it's in the same queuing system as retrievals, and therefore you might need to wait until your verification is done. And therefore it's maybe not useful if you want instantly information on a quick check. What I do normally when I archive data, so I run SLK archive. If it fails, I just repeat it until it succeeds. So it might be for timeout reasons, whatever, that it fails, just run it again and again. And at some point, hopefully it will succeed, everything will be archived. And then when this is done, I submit a verify job. I'll show you the command for it soon. And then I need to wait some time and then I check the result. The disadvantage is, so as I said before, this command, it's queued. This is a queue. This verify job, and it only checks the size. So if there's a bit flip in the file, so for some reason one bit in the file changed, then it will not detect this. But most cases will nicely capture this. Examples is the last set of examples. So how does it work? We have a command SLK helper submit verify job. We can provide a folder here. We provide a folder. We have to set -r for recursive checking. And then we get a lot of textual output. And it's also there because if there are too many files checked with one archival job, it becomes slow. And therefore, if we want to check more than 50,000 files at once, then this check is split into multiple verify jobs. Very jobs.
Right.
And what you get, it's a bit here hard to see, and you get a verify job ID. When multiple jobs are submitted, you will get multiple IDs. So for example, when I do large checks, then maybe 10 jobs are submitted and I get in 10 rows, 10 different IDs. And then I can check with another command called SLK job status. I can check, and then I provide the job ID. I can check the status here, for example. I see, okay, the job is in the queue and on place 28. Then there can be status processing, and in the end it's completed. When it's completed, I can run a command SLK helpers result verify job, provides the job ID, and then I get something like this. I will get first a line written errors, and then there's a list of files which is issues, and also there's a type of error is printed here. So the common error is a size mismatch. This is actually the case for the files which I showed you, so which have the wrong, which are not completely archived. What you have to do there is just one SRK archive. Again, it's simple. You can archive each file individually if you wish, but you also can just run the same SRK archive command as before, and it will automatically skip all files which are correct. They will be skipped, and only the damaged files will be overwritten. What's important here, as you see, is maybe you remember the one file. So these are the original sizes which you had in my first slide on this topic. The one file, it was, so we see here the output here of the new SRK archive command to re-archive everything. And you have here the size after the first archive. And you see this file, the files which are okay, they are skipped. This file with an A, this is a partial flag, this was also skipped, but we also see that one file which also seemed to have the correct size, but also newly successfully archived. So even if the file size looks in the first view correct, it might not be so. Maybe a few bytes were missing, but they are not shown here. And then you see that the other files, the red marked files, are all successfully archived. And this should also show you that just looking into SRK list output, it cannot be used to verify file archives, but really we have to use other tools for this.
Why was the A file listed as partial and now it was skipped?
Yeah, that's a good question. Actually, yeah, I forgot to add a slide on this. Good to ask. So the point is, the way SRK archive works is, so it copies a file, and when the file is completely copied, it needs a few seconds to realize the file is there. Maybe it checks the file size or other stuff. And so when the file archive starts, first this flag is set. And during the whole archival period, the file, this partial flag is there. And when the archival was finished successfully, then it's removed. And when you kill the SRK archive process between the archival was completed and removing the flag, then the flag remains there. And therefore we have files there which are flagged, but they are okay. What is important here, the two files which had the flag and were skipped, they are really skipped and they still have the flag, partial flag after. So this is the listing after we did the re-archival. There's a bug in SRK, so SRK really, it does not touch the file at all. It sees the okay, everything is okay, I don't do anything. You're laughing, so it's the way it is. And the flag is not removed. And you can do this, and we had a lot of tickets in the past. Users ask, oh, I archived the file 10 times and still the flag is there. What should I do? And so you can delete it if you wish, but the easiest way is to just notify us, you send us an email. We cannot remove the flag, but we can ask the Stronning support the developers to remove the flag. So if you have this case and if you are sure the file is okay, then just write us an email, send us a file list, and we remove it. And commonly, when you notify us, then I also do a brief check. Does it look reasonable? So that if you accidentally send a file name, then try to verify if it's really okay. If you send 1,000 file names, we won't do it, but if you send 2 or 3, then we do it. Another thing, so just this is a last example slide. Here we had only this resource content size doesn't match. In the end, you have a summary line, so it's important you have a start line, errors for the error list, then 1 line per error, and then you have a summary, 5 errors. What we have here, we have an unexpected error. This I colored it the violet. There are some metadata issues. So the archival was also cancelled in some situation where a metadata operation was somehow going on, and there's something strange. This you see it, there's a warning, and then you see 3 errors, and you get a message in brackets. Some errors have to be solved by DKRZ support. Please contact support@dkrz.de. So this is when unexpected errors occur. Right, and then it's actually a good thing to just contact us via or contact email address. If you wish, you can do a short focus break, but we'll skip to the summary. So what I talked today about, gave a broad overview of SRK archive, the usage, how to capture exit codes and use exit codes of SRK archive in scripts, pack data quickly, determine the storage location of files with cache or on tape, and how to verify archive files. And I'm open to your questions. Yeah.
My question was, when can you, if you're archiving something from the raster file system to the archive, when can you delete the file from the raster file system? When's that safe?
You mean when you're, okay, commonly, let's say if you are sure that, so in my case, I do it the way I archive the file, I run the verify job, I see in the end, the verify job does not print my file as a problematic file, then I delete it.
Okay, and so it doesn't matter if it's just in the cache on strong link.
Yeah, so let's say if we have a bad, so there might be a bad situation which we didn't have until now, where some of the cache is destroyed for some reason, but the tape archive not, then yeah, then it might be bad. So if let's say it this way, so there might be situations where the cache is emptied or where the cache is not accessible. Mostly in these situations, the tape will also be not accessible. But to be on the safe side, you could wait until the file is on tape. You could use this is on tape command of SRK to check this. So because the file might still be in the cache, but it's already on tape. And this would be the safe way. Yeah, the safest. Regarding Garching, for example, if you archive to double, you have no possibility to check whether the file is also in Garching or not. You cannot check that at all. It's normal user.